Chinese remainder theorem with 3 equations is more complicated than for 2. Here I'm looking for a number that when I divide by 3 I get remainder 2. Same number when I divide by 5 I get remainder 3. Same number when I divide by 7 I get remainder 2. And this is actually the actual question that they wrote about in ancient China. So the answer happens to be 23, the smallest possible answer. It's true that if you divide 23 by 2, you get 10 remainder 3. Divide by 5, sorry, you get 4 remainder 3. Divide by 7, you get 3 remainder 2. How do we use a process to solve this if it sort of gets more complicated? Well, the answer is going to have 16 numbers in it, so it gets kind of complicated. Let me show you how this works. First, we need to find, I'm going to start with this first equation. I need a multiple of 35, which are the other two, the 5 times 7, which is one more than a multiple of 3. And just using trial and error, I can see that 35 times 1 doesn't work, but 35 times 2 does work. For the second equation, I need a multiple of, if I'm going to have the 5, I need the other two mods, which is 3 times 7. So a multiple of 21, that's one more than a multiple of 5, and in this case, it's just 21. B is 1. And I also need, for the third equation, something that when I'm modded by 7, the other two mod numbers are 3 and 5, so 15 times something. And 15 times 1 is already one more than a multiple of 7, so C equals 1 also. These numbers are going to go into my answer. This is 35A, so there's this number 2. 2 times 5 times 7. This 1 goes with the 21, which is 3 times 7. Oops. I need room for 4 numbers. And this 15C is 1 times 3 times 5. Now, 2 times 5 times 7 gives me remainder 1 when I divide by 3. I want remainder 2 when I divide by 3, so I put a 2 in front of this whole thing. 1 times 3 times 7 gets me remainder 1 when I divide by 5. I want remainder 3 when I divide by 5, so I put this 3 in front of it. And 1 times 3 times 5 gets me remainder 1 when I divide by 7, but I want remainder 2 when I divide by 7. So just glancing at this thing here on the bottom, this thing, by the way, equals 235. 230, yeah, I mean. When you look at this expression, 2 times 2 times 5 times 7 plus 3 times 1 times 3 times 7 plus 2 times 1 times 3 times 5, if I divide it by 3, these two terms don't contribute to the remainder. All that matters is this term on the left. The 257 would get me remainder 1, but if I throw that 2 in, it's remainder 2, which is exactly what I want. On the other hand, if I divide by 5, then these two terms don't contribute to the remainder. This 137 would be remainder 1 if I divide by 5. It's remainder 3 if I divide by 5 when I throw that 3 in, which is exactly what I want. And finally, if I divide by 7, these two terms don't matter. This term matters. The 135 would be remainder 1. Throw the 2 in, it's remainder 2, which is exactly what I want. Now 233 is too large, so I'm going to subtract away. On the side, I'm going to do 233 divided by the product of these three mod numbers, which is 105. And it goes in twice, so I'm going to take away 2 of those 105s, so I'll write as 3 times 5 times 7 to get me 23, which is the answer to the question. So that's how you do Chinese remainder with 3 equations.